Hi guys! In this moment I will present the software called Meshi, which has been developed by Pablo Suárez from the University of Las Palmas de Gran Canaria and Miguel Abellón from the University of Holguín, Cuba. Meshi is a MATLAB software designed to assess mesh quality in 3D. With this tool we can study any valid 3D given mesh in relation with a variety of valuable refinement algorithms. Here I will show you some of the more interesting steps of that tool. Enjoy! The input meshes are given by the most simple data structure, point nodes and depths given by those nodes. The powerful of that tool comes with a variety of strategies for the refinement that can be used to refine an input mesh. Actually, mesh refinement consists in iterative subdivision of a given mesh according to some rules already predefined. For example, once we have loaded an initial mesh, for instance, let's say the Abellón tetrahedron, you can rotate and move. We follow then with the application of one of the available refinement schemes in the menu. It can be seen the different refinement strategies implemented. It can be grouped into classes: longest edge based refinement and Delaunay based refinement. For example, in longest edge refinement we have some variation like 3T, 4T, 8T, and so on. If you choose, for example, longest edge, you can apply a different method for element selection: uniform refinement by the threshold value, by the vertex ID, and by the edge number. We choose, for example, uniform and apply with a shortcut several times to these input meshes. And there you have in real time the result. In addition to performing the refinement process itself, one can look into the quality of the new evolving meshes. We use for the study 4 different quality indicators. That by Liu Zhou, which is called eta, which is the ratio between the text volume and the size of edge, relative thickness of the white head, the ratio of radius on the script in sphere and the radius of circumsphere, and finally the solid angle used by Rivara. For example, you can see the evolution of such quality measures so described. You also have the possibility to check for an histogram of the quality, which in this case means that all the elements have 0.8 quality. And also you have the possibility to group by classes in the histogram. You have a method for comparison different refinement scheme in the menu Quality Comparison. In this menu, you just select what kind of tetrahedron you are looking for. For example, let's say sliver. You define what kind of refinement algorithms you will compare. For example, longest edge against longest edge section. You define how many steps will be used for the refinement, for example 4. You select here the kind of refinement, for example uniform, and finally you define what kind of indicator for the quality will be used, for example eta. You run the experiment and at the end you have the result, which means for the blue plot the longest edge and for the green plot the green one.